Hi, I'm Scott Wardle, a senior software engineer on Google Stadia. I'm ex-EA, ex-FIFA, and ex-Frostbite. I've been in games a long time, but these days I'm working on high-performance C# code as I am the Unity lead on Google Stadia. I was having this problem with Stadia Adventures sample. It was a good opportunity for me to learn Burst and jobs, which are great technologies to speed up your code. With that, I had to create a sample to understand these two technologies. And what I learned from that was I was able to separate Burst from jobs. And that was a really powerful tool for me. I'll talk about my results from that and summarize things up. So let's take a look at the problem that I was having. I have Stadia Adventures, which is a Unity title, but it also had a dedicated server as well. These two things just come from different worlds. Unity is well known in the gaming community and is well understood by many game programmers. And so they really like to use it. You build and run, and it'll just happen on Android as easily as it happens for Stadia instances, and deploys and runs right there. Working in dedicated servers is just a different way of working. You end up having to learn technologies like Docker and Kubernetes and these kind of things. It's just a different world. So we came up with a good idea. Maybe we should just move that dedicated server, over to the Unity side. I mean, we're already running in the cloud anyways. What difference does it make? And so running it as a separate thread actually worked really well. There's some cool tricks you can do with Unity too here. You can just drag and drop a DLL into it, and it converted it for us. It was quite nice. We still had to, get rid of one of the two build systems here, but that was a pretty easy problem. The really interesting thing that we hit was when we tried to debug, we couldn't at first. But then we realized that all we were missing is the symbols. As soon as we copied over the PDB symbol files, suddenly my performance dropped through the floor. It was like 2 frames a second, really slow, surprisingly bad. I mean, I was running like 13 milliseconds a frame beforehand, but after this, it was like 600. Just crazy slow. Really, it turns out that most of the problem is in this broad phase collision check function. This broad phase collision check function was 4 times slower once we added in the extra symbols. So this was pretty surprising. But, it's only 4 times slower. We had lots of threads. Maybe we could just use some more cores and brute force it. It turns out that this wasn't going to work for us. As more threads I added to this, the slower the code got. That was really strange. It turns out what was happening is there's this check sequence point function that was getting slower and slower. And inside that function, there was like one instruction called compare and exchange that was making things really bad. I've seen this before, and this is an atomic operation. And like all my samples for Orbit were basically right there. The thing I didn't understand was why this check sequence point was everywhere throughout my code until I talked to Unity. And Unity explained to me that basically they have a cooperative debugger. And so any place that you can put a breakpoint, sometimes multiple times on a line, you're going to have one of these pieces of code generated in. This is the place where the debugger gets its chance to do something. Anyways, this meant that it was really slow and slowed it down things much more than we were expecting. After talking to Unity, though, we came up with a better fix. Basically, instead of using compare and exchange, you can use load relaxed, which is a different type of memory barrier. And if you get this fix from Unity, your performance will be 4 times faster, at least in a really bad case that I stumbled into. But you might find different things in your own code. Now, we're done, right? 4 times faster, great. Yeah, the code wasn't perfect yet, and we were still dropping frames in various situations from before. We just fixed one of the problems. Weirdly, though, if we tried our master build, we were fine. It was running great. It was just, the sort of debug builds, these release development builds that were too slow. It would be really nice to fix them and have them so they weren't dropping frames. And, in some scenes they weren't that fast because, debug builds for a sample is probably the way most of the people are going to run them. They're not going to really make master builds of these things very often. One thing that we also didn't understand was, are people going to take this fix from Unity right away? We didn't really know that. So it was hard for us also to include the PDB file and fix the two build systems and other things that we kind of wanted to do here to make things easier to work with. Therefore, I thought this might be a good opportunity for me to learn about Burst and jobs. Unity's job system is just a way of multi-threading code by creating jobs. Basically, you get one, a thread per core, a worker thread per core, and then you can allow these worker threads to pick up jobs off of a queue. And all these jobs is a function pointer and some data. So it's quite a normal way of setting things up. And I've seen them quite a few times in my career, these sort of job systems. The other technology that Unity has, which is quite unique to Unity, is the Burst compiler. This is a separate C# compiler. It uses a limited subset of C# though, so you can't use everything. But it builds directly to native code. And what this means, at least for this particular discussion, is you're not going to be able to use the managed debugger, which means you don't have sequence points anymore, which also means your code is probably going to go much faster. That doesn't mean you can't debug this code, though. You can still debug it the same way you would debug C++ code. You can use a native debugger. And this actually works better than it does normally with Unity apps. You don't have to debug IL to CPP output. You will be able to debug your normal C# looking code. One thing that does take a little bit of work, though, is you only are allowed to use a limited subset of C#. This does mean you're not allowed to use classes. You have to use structs, and structs are a value type, so you have to be careful that you don't end up making more copies than you expect. That not being able to use classes means no normal container types. You're going to have to use the limited subset of container types that Unity provides, like native array. You can't use list T or something like that. Also, memory allocation and stuff in using the Burst compiler, you have to be careful because you're going to end up allocating memory on the heap. So there's an interesting relationship between Burst and jobs and the C# runtime. If you look for samples of Burst code, you'll always be seeing it used with jobs at the same time. You would think they could only be run together or something, but really they're just like, peanut butter and chocolate. They're just good together. The only problem with this is you have to redesign your code to run with either one of them. If you're going to deal with multi-threading problems for jobs, you're going to have to copy all your data, make sure it's not shared. And with Burst, you have a different set of problems, right? You can't use classes and that sort of thing. One thing that's true for both of them, though, is they both use memory in a different way. And so you end up having to either pin memory in the garbage collector, or you have to use memory on the heap or something like that. But if you do that, then you can use managed code on a job separately, and that is actually possible. Let's see an example of the code, because I think it's always more concrete if we look at it that way. So you have your structure that's Burst compiled, and it will inherit from an I job of some sort or another. And then you'll have a whole bunch of native arrays in it. If you look, at samples on the internet, you'll see things like this. It's quite common. The other thing is you'll have some managed code which will initialize or destroy these objects, clean them up afterwards or set them up. You're also going to have an asynchronous function which will be your main update. And this is the thing that's going to be run on a job. When you boot up, you're going to maybe put it in your awake function, or on your destroy, you're going to have to free up all of your objects. These is just working with those native arrays I showed you in the previous slide. On the update, so maybe every frame or something like that, you'll kick these jobs off, and then they'll start running asynchronously, eventually updating once those job threads are freed. And to make sure they got finished at some point, maybe at late update, you can complete them, which will wait, and then free up all of the temporary memory that you made. So finally, I get a chance to actually try out what I learned. I go back to my Stadia Adventures and start playing around with that server thread again that's running like 13 milliseconds or so a frame. I've already threaded this code before, so it was pretty easy to move over to Burst and jobs. But when I tried to kick things off, it just told me I wasn't allowed to do it there. So this was disappointing. And I wasn't really sure what I was going to do because, I don't really want to run it on the main thread. My main thread is doing a bunch of other work. It's doing all the rendering and AI for the client and things. Maybe I could just move everything to a job. That worked pretty well. I could move the whole server tick to a job, but when I tried to kick off, this collision code, that didn't work either. Apparently, you're not allowed to make a job from a job. So that's too bad. So I was kind of back to the drawing board. I had to explain to my team that this is all going to take me longer than I expect. We want to sort of continue going this direction and things. And well, you can see that obviously I'm making this these slides. So obviously I continued to work on it. But also at this point, we decided we should make a test app so we could understand this technology better. And this is a good thing to do as long as you make a small model of your problem, as long as it's not too simple. This is a good way to go. So here's kind of what my test app sort of look like. I mean, each row here is like some set of threading technology, and each box is like one thread on that. So like the top row is just no threads. The next row was using the task system from Microsoft, which is like Microsoft's sort of job system. Then I used Unity's job system. And this got me sort of an idea of, what was the performance differences between these systems. And then as I sort of went down further and tried more complex things to understand what I could do, because I was trying to figure out like how to, run this Burst job with my other managed code of the server thread. So, maybe it sort of looked like this, I was thinking as a model. So I tried out, situations like that, like run a little managed job, then, some other job, then another one to sort of clear it all up. But this isn't quite the right model. This is too simple. If you look at the code in more detail, the server tick looked more like this. It started off, the server tick ran for a little while, then it hits the physics system. The physics system is not running at 60 hertz like the rest of the server tick is. It's running at 300 ticks. So, it's looping through 5 times with a little delta t and moving along like this. And I wanted to put that broad phase collision check right in the middle of that and call it 5 times. And so this was looking complicated to do this with jobs. So I didn't know what to do again. But fortunately, I know a few people at Unity, and I talked to somebody on the jobs team about my problem. And he said, oh, hey, you know that you could use Burst.CompileFunctionPointer, right? And I'm like, no, I didn't know that at all. And so apparently you can separate Burst out and not use it with the job system. And then you're basically just calling a function now. You don't have to worry about solving this, having your code run asynchronously to everything else, which made things much, much easier. So these Burst function pointers are only allowed to call static functions, and therefore you're going to have to pass in all of the context somehow as a pointer. The easiest way to do this is to require some unsafe code. This worried me a little bit, but it turned out that wasn't much of a big deal. Of course, I couldn't asynchronize this code anymore. Like I couldn't run it as a bunch of threads, but I didn't really need that speed for this. I just wanted to get rid of all of that debugging information. But the real thing that I struggled with with compile function pointer was there's just not that much documented on it. There's not as many samples and things, and I couldn't find anything that was the level of complexity of even my sample app. So I had to trial and error to figure out how to work on it. This is the code I came up with. So to start, I have sort of, two objects. My first one was some managed code that would own my burst call code below. And there's like a garbage collected handle to make sure that the burst call didn't get freed. And there was the function pointer that I was talking about. The burst call itself started looking a lot like the burst job code that I wrote before. It had the same sort of native arrays and things in it. But this was the code that was sort of trickiest to write. That I had the most amount of trial and error to figure out. Basically, it's unsafe code that just takes in one parameter, which will be my burst call itself. But getting that burst call and turning that pointer into something I could call without making a copy of anything was a bit tricky. Turns out the best thing you should do is pretend this pointer was an array of one size and just dereference the 0th element and then kind of like cast it into place. And then from there, you can call into normal safe call code again, update all your native arrays. On the managed side of things, you're going to create all those native arrays again. I then had to pin this data, though, and this was a bit surprising in that it ends up making a copy, a shallow copy of my data. So it didn't copy the image data, but it did copy a bunch of pointers and sizes. And I'll talk about that a bit more later. I have to make the function pointer, of course. This was fairly easy to do. A little long, but other than that, it was fine. There was managed code to run every frame. Then I could call my function pointer and pass in that pinned object data I was talking about. And then, I could finish off the frame with some more managed code. So I just wanted to talk a little bit more about creating these, this burst call and why I ended up with an extra copy of it. Burst calls are structs, so they're value types. So usually when you create a value type, you can kind of do this, fairly easily, just like anything else. In managed code, you new these native arrays and then pass in, them and set them to sizes so that they're big enough to have my image data. But when I pinned them, because they are a value type, it ended up having to make a copy of them. This doesn't mean I made a copy of the image data. I just made a copy of the actual native arrays themselves, which are just some pointers and sizes. So that isn't too big of a cost, but it is a bit of information that you need to know about because it might change things on how you use it, right? When you call into the burst function, though, you're using a reference again, and the reference points to the pinned version because that's the one that's never going to move, where the one from the first step might move. The real question here is, how do you free this up? Turns out you free the first one, and you're just going to call dispose on that, and that'll free it up. And then you can free up the actual handle itself to the second one. Now, if you tried to free the second one, what you would end up getting is this error. I'm guessing there's just a system here that makes sure that you're not freeing things twice, and because they have two sets of pointers pointing to the same data. So they just force you to do it one way or the other. So results. It looks like I got the speed that I was thinking of by removing the sequence points. I did get 10x faster. In Burst, for the master builds as well, this was faster too. I think the speed gain here was because I would improve the caching situation because I had to copy data out of a bunch of classes and put them into structures in order to make Burst work at all. And in doing so, I ended up optimizing it because I could make it smaller, better organized data for the particular problem I was solving. For Raindrop, I also got pretty good gains. It wasn't quite as much of a difference for the release development build, so the debug data maybe wasn't quite as much of a problem. The master build here got 1.7 times faster as well, but How it ended up doing it is a bit different. The code must have just improved because, I didn't have to reorganize the data in this case. They were working with image data in both cases, so the shape of the data, the caching of it, shouldn't have changed. But obviously it's generating better code still. So just to summarize things up here, development builds can be made much faster in Unity. So if you're having a problem with your debug builds, one, get a fix from Unity. That might make it 5 times faster all on its own. And the other thing you can do is, use Burst on particular places, and you might get another 5 to 10x there. If you ever do have complex problems like I was, maybe making a test app, as long as you don't simplify your problem too much that you're solving a different problem, that's always a good idea. Finally, the real takeaway from this whole presentation is Burst and jobs can be used separately. You can decouple these two systems, and all you have to do if you want to use Burst by itself is use CompileFunctionPointer, and then learn a little bit of unsafe code and a little bit about pinning in a garbage collector. Note that you might make an extra copy of your data, but it's only a few pointers and sizes, at least in my case, but it is something to be careful of. Finally, last but not least, the real trick here is you're going to need to use like read array element to, cast your context data into a reference of your class type, so you don't have to be dealing with void data anymore. One other thing that I wanted to talk about was that you can call manage code from a job. And this is pretty easy to do. You do have to do some garbage collected pinning, but you'll be pinning a class in this case. So anything that class references will also be fine. So that works really well. There is some samples on the web that do this, and so I didn't really talk about it too much here. So anyways, thank you very much for listening to my presentation. And I will try and post the code samples for this soon. Thank you very much.